Now we're going to combine the two ideas that we've played with so far, vertical and horizontal rigid transformations, and see how applying this at the same time works. So the graph of fg of x is shown below. Graph x plus 3, graph g of x plus 3, parentheses plus 2. So now we have two things going on. We have a transformation affecting the input variable and another transformation affecting the output variable. So just like before, it's just easier to graph or write a few points down. And this is a rigid, so as long as we grab the points that are sort of define the picture, then we can redraw pretty easily. That's all we need to do. So we have 3 clear points. Write those down in a table. And we can apply one transformation at a time. So if I apply, for example, x plus 3, I know the y is going to stay exactly the same, so I'm going to leave this alone. That's not changing. Could I do this at the same time? Sure, you could. But for now, don't. So again, the question now becomes, what do I need to enter here to get -5? Well, if I enter -8, -8 plus 3 is -5. What do I need to enter here, then into this function to get 0? Well, if I enter -3, -3 plus 3 is a 0. What do I enter here to get a 2 when I add 3? Well, if I were to if I entered a, see, 2, right? I want a 2 back out, so let's enter a -5. So enter -5, and -5 plus 2 is 2. Yep, and that does work. Fantastic. Again, just verify. So another way of thinking about this is I'm going to move everything. So I can change the addition to subtract, and then the opposite of 3 is -3. So it looks like I've taken every x point and subtracted 3 from it. Let's see, or added -3. Let's think of this way, added -3. So -5 plus and -3 is -8. 0 plus -3 is -3. And this is the only thing not work out to do. 2 plus -3 is -1. So is that right? Yeah, I didn't think about that. So notice again, with a little verification, I didn't get that right. I want the input to be, what's the input? So the output is it looked weird to me, but I'm just a little tired right now. So yes, if I enter -1 plus 3 gives me 2. And indeed, if I take this point and shift it 3 units to the left, I get -1. So now I'm ready to regraph this picture. 5, 3 goes to -8, and it stays. Oh, I'm not ready to graph yet. Sorry, I'm not done. So I've applied just this one right here. The next step is to apply the +2. So let me graph one more time. So I took care of the input. So that means I'm not going to change these, but I'm going to write them down again. Why? Because I'm not messing with them. The only thing I'm messing with now is the output. And it says add 2 to the output. So I know this is connected to an equation function, but the reality is that the reason this is so important is that we start understanding that if we're doing a composition, notice what's inside here is a line. This is linear. And when we're affecting the output, it's also linear. In this case, in both cases, I'm just adding a constant. It doesn't change the shape, so I can sort of individually handle things as long as I understand how all this works. So now the y value is just going to be a 2. Add 2 to everything. So 3 plus 2 is 5. 5 plus 2 is 7. and 0 plus 2 is 2. So now I'm ready to graph. So where did this point go? It went to -8 and +5. So notice that point has shifted 2 over and gone over 1, 2, 3. What about the next one? -0, 5. 0, 5, where did it go? It went to -3, 7. So again, -3, 1, 2, 3, and +7, 1, 2. And again, notice 3 over, 2 up. That's what it's saying. 3 over, 2 up. Last one is 2, 0. Where'd that go? Again, 3 over, 1, 2, 3, and 2 up. 1, 2. And again, -1, +2. And now I'm ready to rejoin these dots, those order pairs, and I got my new graph. Write the equation of a shown graph. Okay, so it looks like the square root function. In other words, it just looks like f of x equals x squared. So I'm going to pretend for a moment that this is 0, 0. I know it's not. This point is not 0, 0. This point is -5. And what's this point? No, not -5. +5. And let's see. 1, 2, 3, 4, 5. Yep, it is that correct. So that looks like 1, 2, 3. So -3. So it looks like it's going to be 5, -3. So I know what that is. But for momentarily, just in my mind, I'm going to think of this as the origin, 0, 0. So I just want to verify a couple of things. If this is really just if the basic function is square root of x, then, and I call this 0, 0, then if I enter, for example, 4, 1, 2, 3, 4, I should get 2 back out. 1, 2, yep, indeed. If I go 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. The square root of 9 is 3. 1, 2, 3, yep. So indeed, the basic function is just that. The question is, how do I go from the basic function, again, basic function being 0, 0, 4, 2, 9, 3, which is sitting here. Right? How do I go from that picture to this one? What's the equation? Nope. All I have to do is follow, since again, this is rigid, and that's why I did this little checkpoint here, just to make sure that these points are just being rigidly moved, not twisted in any way. It looks like I moved 5 units to the right. So if I'm going to write this again, call this again, this one, new one here, g of x, and I'm going to write this in terms of, let's say this one is f of x. So writing in terms of f of x, I'm going to write g of x equals and write everything in terms of f of x. So it looks like I moved 5 units to the right. So notice again, because I did that, I'm going to just, then if I start with subtract, I just need to write down the correct movement. 5 to the right, 5 to the right is positive. And the last thing I did was go down 3 units. It looks like, right? This point went 1, 2, 3. So at the end, I'm going to just do subtract 3. If I want to write this not in function notation, but as the equation, all I need to do is, here is my basic function, f of x equals square root of x. And now I can just dump this in. And then at the end, subtract this. So again, so we've been practicing with function notation for this purpose, so I can quickly now just be able to write the equation, again, using these transformations. Did we get this right? Let's just go to Desmos and find out. So you can verify a lot of things that you're doing. I'm going to come over here, right? SQRT, X. And I think the equation is this. X minus 5 plus, no, minus 3. And yeah, that looks right. 5, negative 3. Yep, that is the correct function. One more here. Write the equation here, g of x, in terms of f of x. So again, same thing, g of x. I want to write down in terms of f of x. So it's just the same thing I did here. What's happening? Well, if I look at this picture, I can see that it's just this picture moved over. So I just need to figure out this point is 0, 0. Notice a lot of these are 0, 0. Just to get it, it's easier when it's 0, 0, but it can be done with anything. And I go 1, 2, 3, 4, 4. Looks like a 4 and then down 1. And there's that point. So at that point, 0, 0 has moved down to positive, to the right 4 and down 1. So again, having said that, it looks like, and here's my template. Notice I'm going to go x minus. And now I'm going to write down the horizontal shift, which is a 4 to drop it in. And then the vertical shift, because I'm going down, notice now the direction, I'm going to subtract 1. So now, that makes sense to just say subtract 1, or you guys say add negative 1. And there's my function. I don't know if you recognize this, but the basic function here is x cubed. So now let's see if I have this right. I'm going to bring decimals back again. So again, this class, part of the, what I want you to do is be able to write down these basic functions. That way you have a library of functions that you can rely on. And besides, this one we're going to see later on and play with a lot. So there's my f of x equals x cubed. Then what did I say this f of x was? It's x subtract 4 and then minus 1. So I come over here, subtract 1, and oops, not 12, minus 1, yep, 1. And there it is, 4, yep, looking at my picture, it's at 4 and 1. Come over here, clap, yep, negative, positive 4, 1. I am fine, that is correct. So again, we got a little bit of taste, just applying these now simultaneously.